Abdulfatai Sanusi is a geospatial developer at Proforce Galaxies in Lagos, Nigeria. A couple of weeks ago, I put out a call on LinkedIn asking for guests to talk about utilities. He was the first to respond. We had a great conversation about the nearly 5 years he spent working at a power utility in Nigeria. It was nice to hear of the success they had in migrating from one platform to another. It was also gratifying to hear that some of the same issues with utilities that many of us have in our own countries also happen in Nigeria. We then moved on to his work at Proforce Galaxies. They run their own Earth observation constellation based on satellites they design. It was great to hear they're keeping up with the latest trends, such as selling access to spatial data intelligence pipelines based on these satellites, rather than just hoping people will buy the imagery. My name's Wilfred Waters. Without further ado, thank you for listening to Geospatial FM. Abdulfatai Sanusi, an employee of Proforce Galaxies Limited. It's a privilege.
All right, the pleasure is mine. It's nice to be here, Wilfred. I've seen a lot of your podcasts on YouTube and Spotify. Really much impressed, and it's nice to be here.
Great. Yeah, I'm glad I've got a listener all the way down there. I'm happy with my marketing efforts.
Yeah, it's gone far.
All right. So you're the second guest we have from the continent of Africa. The first one was Aya Data from a couple of years ago now, talking about data science in an agricultural and a crop monitoring context. So how I got to you was sort of putting a word out on LinkedIn saying geospatial, we need to talk about utilities. And here you are. So I'd love to get to your experience in utilities and just open the audience's eyes to how that is done in Nigeria. I think there'll be some fascinating, relationships, or that there will be a lot of commonalities between or across countries, really, in this space. But what I'd also like to start off with, actually, is just an overview of your career in Nigeria, how you got started, how it's been, and to hear some reflections on these 6 years you've had in this industry.
All right. So it's all started like back in 2020. I was like the first hands-on experience I had about GIS. I worked in a company called Geotechnics Service Limited. They are mostly like environmental sector. So they carry out contracts for the government for environmental sectors, lots of contract, and that was how I kind of got started in GIS. I think we were still using ArcMap. There is ArcMap then. It was kind of fun. I had to learn a lot of stuff on YouTube, get an idea of what GIS is about, and I did a lot of field works, like lots of field work. So I spent like 3 years there, and I moved on to be an intern at the electricity company. Then a few years later, I got a job there as a GIS analyst, which is what kind of prompted today's podcast, Geospatial in Nigerian Utility. So before I dive into that, let me just explain the organogram of electricity in Nigeria. So in Nigeria, we have three major sectors when it comes to electricity. We have the GenCo, that's the generating station. We have the transmission station, then we have the distribution. So I worked under the distribution station because it's kind of the largest. They generate electricity, they transmit, then we distribute to customers, government, and the public. So I worked in the distribution aspect of that organogram. And I mean, when I started, it was kind of nice because to compare it, let's say, when we kind of compare to, let's say, the United States or Europe, they've kind of employed GIS to utilities. And to my surprise, some discos in Nigeria have started using GIS already. I mean, the disco I worked at, they kind of employed the use of GIS late, but some discos, for example, the one in Lagos and some other ones, they started early, so they had the edge over other discos. So when I started there, the major issue my team and we came across was the issue of data, because in an electrical company, they would want to have geotagged data, data for the transformer, for the electric poles, electric cables, and customer data. So they kind of outsourced the contracts to some certain set of people to gather the data, which they did, but it was not really accurate. So a few years later, we got employed into the company and they created a new GIS department. So the first issue we had was migrating the initial data they have to S3 Enterprise. It was still on Microsoft Azure, so it was kind of easy to migrate. So we migrated from Microsoft Azure to Microsoft Azure, but this time around under S3 Enterprise. Then the first issue we had was the schema, the database schema of what they used to capture the data years back was way different to what you have now. The attributes table, the topology, the everything is way different. So it's as if we have thousands and thousands of data, but they are not correct. At least let's say 40% or 50% accurate. So we could not really build on top the existing data. So
I have to ask a couple of questions there, Abdulfatai. So
yeah.
first of all, talking about Microsoft Azure, my eyes lit up there because actually we've had a guest, Clayman Sahot, on in the past year about Azure Maps. And through that, I discovered there are all sorts of out-of-the-box geospatial processing tools that you can, that are available in Azure Maps. And there's a whole web map authoring, function as well. So there's a strong geospatial capability that's attached to Azure, and you've got the backing of, the Microsoft ecosystem too. So it's interesting that that's how you guys started, and that, some people might think it was a step backward going to Esri. So for the migration to Esri Enterprise, was there a APDM or UPDM schema involved? And did you guys also use a geometric network or utility network? Tell us about some of these details.
All right. So for we used mostly the utility network aspect, and the time they used the Microsoft Azure, I think they just used the database to store all the information that was picked from the field. So they kind of just stored it there. Then we needed to have I think it was around that time S3 was kind of popular here, and since they saw other electricity company in Nigeria, they were kind of employing the use of S3. So we decided to migrate from the database we have, bring everything onto S3. So that was what we did. And as I was saying, the major issue was we wanted to build on top of the data we have that was captured years ago, and we noticed the disparity in basically everything. The database is different. The location of each asset is different. We kind of loaded the location on what is it called, an ArcGIS Pro, and we noticed some of the assets was shown in Ghana, in Tanzania, and Pacific, Atlantic Ocean, and that was a huge error. So we needed to correct that. So what
It's so nice to hear that the same problem exists around the world for all utilities, and we all have the same problem.
that's it is structural. So what we did was we could not like just discard the data because they gathered it through a lot of effort. So it needed at least a little bit of cleaning before we could use it. So we started with data cleaning. We used ArcPy because it's made the migration faster, because the manual process of doing the correcting the attribute table, the fields, the domain design, it's stressing. So we automated that using ArcPy. So it was kind of, the process was fast since we had the schema we wanted to use. We scripted everything, ran the script, generated new fields and new domain, new topology, new rules. So once we were sure that we had that correctly, we set out for field work. So that's when we use the field maps, the survey 123 and the ArcGIS dashboard. We gave out the field technicians to go out, capture new data, then we kept on updating the previous data. So that's where we were able to kind of make sense of the old data, then That was how at the Disco, the company, they were able to generate new data and also perfect what they have. So
Amazing. Okay, so
okay.
you're into the area of as-built, and also this tough challenge of how to efficiently and easily, with as few human data, manual handling touch points, um, get the reality from what you excavate and what you bury, or in the case in terms of your buried power cables, or what you string between pylons, get that reality into the database with as little delay and fuss and bother and error as possible. So it sounds like you said were you using collector, field maps, survey
Yeah,
123,
yeah.
those
So
are Esri mobile applications. It sounds like to ground truth or verify your existing data after the migration into Esri Enterprise, and into the custom schema that you created from Azure. So then you had it in your hand, walking around to verify what was at site. And it sounds like, are you then editing it from the mobile device, or at least somehow recording what it actually is if it's different from what the post-migration data had?
we do not want to duplicate assets, so they have to confirm if it has been captured before. So once they get to the position and it hasn't been captured, they will have to recapture it. Then people at the back end, we at the back end will have to verify if it has been captured, so we can delete the outdated one and leave the new one has been captured. So that was what we did for the past, let's say, like 2, 3, 4 months. We were cleaning data and recapturing, cleaning, recapturing. So it got to a point, at least we were okay with what we had. Then we proceeded to creating dashboards and story maps for the stakeholders because they have to see what they were investing the money into and see the progress. So that was it. And the major goal for, I think, once it comes to utility in Nigeria, what they want to achieve is to reduce losses. Because I said earlier, the schema or the organogram in Nigeria when it comes to electricity, we have the generation station that generates, transmits, then distributes. So the major goal of the distribution company is to generate revenue. And the only way to generate revenue is once they distribute power to the public, to the government, to companies, they need to get money in return. So the companies and governments, they do pay, but the public, the citizens, they tend to default on the payments. Some like they bypass, what's it called? They bypass, bypassing means they use electricity illegally without paying. So we had all those issues and it was affecting the targets, the yearly targets, which was set by the Electricity Commission in Nigeria. So GIS played a major role in that because once we had customer data and we had asset data. So we mapped out all the customer, we mapped out all the assets, and we had the line data. So each customer is tied to a certain transformer and is tied to a certain electric cable and electric pole. So with that way, since we had a good data that at least let's say 80-90% accurate, we were able to estimate the amount of revenue we would generate from a building. Whereas before GIS, in a building, there might be, let's say, 100 rooms, and they would just like 20 rooms are going to pay. The other 80 are bypassing. But with GIS, we know that in this building, there are 100 rooms. We are expecting revenue from 100 persons. There's no way to bypass it. We're able to cut that issue, and GIS really helped with that. I mean, it's helping. It's helping.
Yeah, this has reminded me of spatial finance, and this issue of clustering of fraud. And there was an example actually from California, of all places, I think in relation to fraud in the aged care system. And they noticed that there were there were clusters of fraudulent businesses in one office building, like hundreds of them. So it's interesting that there's in a similar way, once you've got, 80 to 90% there, accurate and complete GIS, in this case about a power utility network model, you can then target your fraud or abuse, the efforts to combat that. So that's a really interesting point too. So I asked before about the data model or the schema that was used, only because at least what's common in the US where I am, and in other countries, it can be common to use as a starting point the utility pipeline data model, or similar ones for power or other types of utilities from Esri. So are you aware of UPDM or similar ones? I think there's pods as well. There are a few efforts across the industry to come up with generic data models that you can use, and then maybe you can customize them. Is this done in or used in Nigeria?
Yeah, so electricity in Nigeria, it's a little bit different from electricity in, let's say, US. I mean, it's kind of similar, but um, there are a little bit of differences. So for the module you asked for, we searched on what is called GIS solutions. So they have S3 has lots of pre-planned and everything has been done, like has been organized. So we used the solutions that was designed for electricity. Then we kind of the one there is a little bit, it's works perfectly for a US like structure network, electricity network structure, but we kind of implemented it for ours, then made a little bit of changes. Changed the for example, there are some ratings, electricity ratings that is used in US that we don't use here. So we needed to change that and migrated everything to what is suitable. But the baseline for the new database we're using was the S3 solutions on the one provided.
Yeah. Okay. All right. I'm aware of that website. I think a lot of us in the
Yeah.
geospatial for utilities space will be aware of that webpage. Okay. All right. So I wanted to dig into as-built a little bit if we could, because so I've had utility experience in the context of a sewer network, and also utility experience in the context of power transmission. So the sewer experience was in Doha in Qatar. The power transmission was in South Australia, in Australia. And I've also had gas transmission experience in Georgia in the US. In all of these experiences that I've had, there has been an issue with processing as-built survey data, and significant delays. You won't believe it, but of the order of 7 years delay in bringing the as-built survey data into the GIS. What are the formalities and systems around as-built surveying from your experience in Nigeria? We can start there. And if there are none, then we want to hear more
All right.
about how you got there.
Prior to when the GIS team was created, then they kind of went the old way of using Microsoft Excel. They had a template of storing any new assets. There's a template they follow, the description of all the attributes of all the assets, then the location, the latitude and longitude, because they kind of had plans that years later they were going to get a GIS department, and if they were to function, they need something to feed on. So that was kind of like the saving grace. They went back to the old school way of using Excel, storing manually. Then it was easier to convert from CSV to shape files. Then from there, we built the database. So I think the old school kind of helps sometimes. It helps.
Yeah, absolutely. And I mean, I'll tell you about the value of an independent record in PDFs. So there's a massive transmission methane pipeline going from Central Australia to Sydney. It was of the order, I think, of 1,600 kilometers. And I had a project during COVID. So it was the middle of 2020, so the same year you started your career. and they lost trust in the digital record of this pipeline, and they needed to go back to the alignment sheets from like a decade ago. And I had to go through 600 of these alignment sheets and digitize every single last detail, all the bits of equipment, all the valves and everything hanging off this pipeline, and put it into spreadsheets so that it could then be reconstituted digitally to compare with their digital record that they'd lost trust in. So yeah, there is this phenomenon, it seems, in multiple countries. It's just how utilities are done, or how asset management is done, that we will need sometimes to fall back on the old school, or the hard copy, as it were, record of the asset. But I guess what I was trying to get at in terms of maintaining the live system, and for example, if you wanted to build a new power line, right? Is there a formal professional surveying team which will go out there and do a highly accurate survey of the positions of the pylons, and then you can infer from there the stringing of the conductors between those pylons. I assume that there was a professional survey team who was responsible for generating those as-built surveys that were then signed off, stamped probably by an engineering team, and then there was a procedure after that to convert that survey data into new records in the geodatabase.
All right, so let me use transformer, for example. So to install a new transformer, like before they had a GIS team, what they do is the old engineers, they do the AutoCAD drawing, and based on the data they have, they do the AutoCAD drawing, and they go for a field survey, then they execute the operation. But now that we have a GIS team, because in Nigeria, at least where I was in Nigeria, before we can install a transformer, we need to determine the location. It has to be like in a central position so that it can feed a lot of people. And with GIS, it kind of made it easier since we add the base maps, the exact replica of the real world, but in a digital form. We carry out, okay, let's assume we place the transformer here. How many people is it going to feed? What will be the difference between placing the transformer in this position and in the proposed position that was made by the AutoCAD, and what we have by the GIS department? So now the GIS department had a big say, because they have to follow what we decide. So any schema or any diagram they come up with, they bring it to us. We do our verification. Then once it's okay, we approve it, and we push it. Then they can go for a field review. Then they capture any geotag, any information that is necessary for the GIS department and is also necessary for the engineering team. They bring it back, then we can work on it. But they need to pass through the GIS team first before they can carry out anything.
I love this characterization of the value of spatial analysis, when you can see the demographic data, the population density data, also industrial clusters, because you've got non-residential, you've got commercial, industrial users of electricity. The picture you're painting is how, when you put everything on a map, you can more easily analyze the optimal position. Or it's a site selection analysis. So you're into the realm of multi-criteria analyses and things like that. Is that what you're illustrating here?
Yes, that is, and most importantly, we have to think of what's called revenue, which place would generate more revenue, because we are all about the revenue aspect. Yeah.
Okay, amazing. So I think something to bring up here now, and it's again coming back to the context of this episode happening at all, where I said geospatial, we need to talk about utilities, and then we had a brief discussion, and I appreciated this. So the reason why I brought this up at all is that, correct me if I'm wrong, but it seems like, roughly speaking, there are three systems that are maintained. You've got the spatial system of record. You've mentioned the term geodatabase, but you're also talking about Esri Enterprise. So was there like a back-end database like Oracle or SQL Server that underpinned the SDE? Or did you just have a regular file geodatabase?
No, we relied entirely on Microsoft Azure.
Okay, so then effectively underneath that, you would have something like SQL Server, right? So a proper object relational database management system. Okay, so
Yes, we
that
do.
to me, in my thinking, is like the spatial system of record. Yeah, and what's important there is without any other software, you can actually do spatial SQL against that database, and you can do SQL analyses using measure data, actually, the M values, for example, to bring back for, um, what in the first 50% of this bit of the network on this particular line, what valves, or in the case of a power system, what transformers or what pylons are in this first 50% of this transmission line. So just to say that there is a lot of powerful geospatial analysis that you can actually do using spatial SQL against just the spatial system of record. And then you have the system of engagement. So what this does, it sits on top of the system of record, and for example, it is Esri, but you've got all manner of other GIS software out there. I love always mentioning Beijing Supermap in this context, because the Chinese have got their own actually publicly traded company that does GIS. But there's also the specialist network modeling software out there. So from Schneider Electric, ArcFM.
Yeah, we use that also.
You did? Cool.
Yeah,
Yep,
we maybe
that was
Akafem.
also. Yep. So they also have captured some territory in Georgia, and I heard about them in Australia too. You got Small World from GE. You've got IQGeo from KKR. There's Hexagon. There's IkeGPS. There are so many interestingly, actually, specialist network modeling software platforms out there. But just to say generically, these are at least in part, the system of engagement. So it is often where you have a team of GIS practitioner staff. They come to work every day. They sit down at a desk and they've got a turn on the desktop computer. Often it's a more high-powered machine, and they use this software to engage. It's like an engagement layer on top of the system of record, and they use the system of engagement to edit the network. So they will put in new data, they will edit existing data, for example, in response to the field trips that you were talking about to verify. So your activities there in the back office that you talked about to verify the results of the field trips, that's done leveraging or using the system of engagement. And you also use the system of engagement. You also mentioned creating dashboards, things like that. That's also often done using the system of engagement. So, there's a dashboard authoring suite like Experience Builder with Esri, and equivalents in MapInfo or Beijing Supermap. One day I have to have them on the podcast. But then next, so good. We've got those two systems, the spatial system of record, and sitting on top of that, or leveraging it, or writing to it and reading from it, you've got the system of engagement. And there's all manner of different software packages that do that. Importantly, not just Esri. And then you've also got the system of monitoring, which sits downstream from these two. And examples are Ellipse or Maximo from IBM. These are to manage maintenance events and outages and things like that. So events somewhere on the network. So it seemed like in your comments on LinkedIn, you were aware of a similar linkages between these systems. Have you got any comments to make about that?
Yeah, I mean, I read the comments you made on LinkedIn, and I could only think of just one possible reason why people prefer querying on traditional like GIS softwares than the
The system of
database
engagement.
than the same. So, for example, I think people kind of find it convenient to trade on, I mean, sorry, to query on GIS softwares because there is always a risk of it's kind of risky when you query from the source itself. The database is on a safe let's say I want to query, do an SQL query on Microsoft Azure. I'm kind of querying on the database itself. A lot of things could go wrong. But if I query on ArcGIS, I could easily undo if I make a mistake and my data would still be safe. But it all comes down to, it's more of skill issue, yeah, skill issue.
Yep, yep. No, you're absolutely right. And that brings up actually a benefit of the system of engagement because it can, for example, create branch versions or some form of version of the database, and the practitioner will sit there and do their edits to the branch, which is not the actual base version of the database. It's a branch version. And then there'll be some, and often it will be orchestrated using Workflow Manager, which also, it has to be said, comes with its own set of issues, which I especially observed in my latest utilities experience. But when it is working properly, it can be a way to protect, as you're saying, the database against bad edits, because there will be an administrative there'll be administrative protections in place that Workflow Manager facilitates, where the practitioner may complete their work and their edits, and then they push it into a validation queue for the manager to verify before it is finally posted to the base version.
Yeah, I think that sounds reasonable. If they follow
Yeah,
the process, it's okay. That's
yeah.
nice.
I think you're not alone in observing, I'll say this, it can also be intimidating to do SQL, let alone spatial SQL, against the system of record as well, because you're looking at code, and it's just much easier to visualize things on the map, and you have more confidence sometimes. But then you also mentioned skill, and there's a trade-off there, because once you do get the skill, you can do enormously powerful things at scale, and the transaction speeds are just so much faster, because the system of engagement, especially in the context of Esri utility network and all of that, has a huge reliance on services and the servers and the whole network infrastructure that maintains all of those. And if you don't have a skilled IT team that can maintain the health of that system, you will have all sorts of problems. And let me tell you, I saw no end of those. So yeah, did you guys have Maximo or some sort of maintenance or tasking order system as well?
Um, yeah, I think so. Yeah, I think because at some point they kind of wanted to take this a little bit further to like real-time monitoring of outages basically. And I think the
Yep.
company kind of has its own SCADA system, and it was at some point integrated. I think by the time I left, they were in the process of integrating it with their SCADA system, kind of bring everything to life, and not just kind of like static. But since the GIS was up to date, it was kind of easy to integrate with their SCADA and the ArcFM. So it was easy to monitor real life scenarios. So whenever there's outage, we see it on the map. Okay, supply has been dropped here. We need to do something about it and something like that. So that was what they were working on, and I think they've kind of achieved it now. But I think I'll
Amazing.
just have to check up on them later.
Okay, cool. So that's some sort of automated way for the system to know that a transformer's gone down and all of the attached conductors going to residents. Okay. I guess what I was more talking about was in terms of the system of monitoring. For example, you have teams of engineers or technicians who, when the SCADA system says, "Hey, this transformer's gone down," or "There's been a power outage over there," there will be a maintenance event that's recorded in a database, which has, the part of the network, the time that it began, and there will be maybe a day's worth of tasks that the system will package up into a day of work, and the team just uses that in a mobile app
All right.
to instruct them where to go.
Yeah, so we relied heavily on S3 tech stack, and since, as I said earlier, we've cleaned all the data and everything was to some points accurate. So we were able to use the ArcGIS workflow. And so each field technician had his own mobile phone, obviously, and account. So the first thing it does, like once it gets into the office, open your workflow, check if there's any new task that has been assigned to you,
Cool.
fix it, then yeah, that's it. We use the workflow, I guess workflow.
Awesome. So you also use Workflow Manager for the
Yeah.
system of monitoring, if you like, or for tasking for field technicians. Amazing. Okay, great. Out of interest, what was the length of the network or the total number of customers?
Let's see. I think we were the largest of the discos because we covered 5 states and we had 2 million plus customers.
Wow.
And for the route lengths, I've forgotten what it was span across 5 states. And I
Okay.
think the geographical coverage of the 5 states was around 140,000 kilometers squared.
Okay. Great. So you also had some experience in other sectors
Oh,
in
okay, yeah.
Nigeria.
So let me just give a brief about my current role in the defense and security. I think it's been the most intriguing so far because it's kind of gets closer to the action and it creates tools that get used on a daily basis. So the difference between my current role and um, the role I was in the utility sector was the solution I created in utility sector was aimed as like it was used for the company, but this time around the products we create are used by a lot of people, by the government, by other private sectors, and a lot of people. And I think Proforce Galaxies we just started, so a lot of people might not really know us, but we are a subsidiary of a bigger company named Proforce Defense. I think if you search it out, you would see a lot of things about Proforce Defense. So what we do basically here, as I said, we are defense and space and satellite company. We create geospatial insights. We create products. We create build satellites, CubeSats, etc. But let me just focus more on the geospatial product aspect of things. So we create lots of geo for basically all sectors. So now we just think of any sector. We have basically a product for each and every sector: oil and gas, agriculture, electricity, everything, automobile, everything. We have a product that can be used by each company in any sector. So it's really a big deal.
That's so cool. So basically, you're an Earth observation. You have your own Earth
Yeah,
observation satellites. Do you launch CubeSats or regular satellites from Nigeria?
in Nigeria, we do not have a launch site currently, but here we develop and build the satellite, then outsource it to private companies or neighboring countries to help us launch it
Yeah,
for
that's
the
so
building
awesome.
and the
So
developments.
yeah, to tell us about the capabilities of one of the satellites.
All right, so have we have multiple satellites for optical, SAR, and stereo. So let's
Awesome.
focus on the optical for now. So as I said, we have in Proforce Galaxies, we not just create products like your spatial software products, we also create hardware, so example, the satellite. So I work in the software, AI software team. We create your intelligence, special intelligence products. And as I said earlier, we've created basically products for every sector you could think of. And we are currently a new company in road. So we've come out really, we just want to come out like as a surprise to everyone because we've done all the work, all the process, all the tech, latest tech, Geo AI, generative AI,
Yep, yep,
everything has
yep.
been
The
implemented.
usual things. Yeah.
So yeah, so we just want to come out whole. So I think if you check out the LinkedIn page, we've started posting some of the products. You'll see GeoTrace. It's a command and control, just special version of a command and control, just like kind of like Palantir, yeah, but this time
Yeah.
our version.
So cool. Okay. So the last episode that I recorded was with Ryan Kametz, who created Quant Agri. So
So
it's basically artificial intelligence based tool for processing Landsat and Sentinel data to estimate the health of crops and the rate of growth of crops, for example, cotton, soy, sugarcane, whatever, to try to get ahead of the official numbers that are released every month of the amount of commodities available. So, do you also have a agricultural intelligence solution?
yes, as I said, we have a product. And first of all, the name of the product that we created for wholly agriculture is agrivision. So we leverage on hyperspectral data because hyperspectral sees in multiple bands and it's kinds of sees beyond what normal optical can see. So we leverage on hyperspectral data and relative ancestral data. We also have trained AI models that does the whole automation because what we kind of leverage on here, we want to eliminate that manual process of obtaining data, giving GIS analysts manually doing analysis, generating maps. No, so
It's
we've
a
built
huge amount of
a
work to get through that data. Yeah.
so we have a pipeline built such that once the satellite captures, it sends the imagery through the pipeline, generates everything. All that needs to be done is just for a human input, just review the output. So when it's
Awesome.
okay, you can send it.
I love the fact that you use the term pipeline, and that is the overall criticism of the Earth observation industry, that they're all naive, and they all think that we are going to tolerate or have an appetite for looking through the noise in the terabytes and petabytes of data that they throw at us. But really, actually, an intelligent way to run one of these companies is what you said. You need to set up pipelines and sell access to those pipelines. So that's nice to hear about that maturity. Have you heard of TerraWatch Space and Aravind, the guy behind that?
TerraWatch now, but TerraWatch, I've heard of Terra.
TerraWatch is it's a newsletter. It's also a consulting service. They ran the EO Summit. They've had one in New York City last year. I went to it. They have one in London as well. Aravind Ravichandran, he was a software developer and he went into this consulting area. And he says similar things. It sounds like you're aware of the same things he's aware of.
yeah.
Okay, that's really amazing. There's also a reference there to another podcast guest I had, Novi, Michael Bartholomew, the CEO of that company, basically was talking about edge computing and running these processes on the satellite, so that you are not sending down data unnecessarily. Can you speak to that?
Yeah, it's that's the goal. Like as you said earlier, no one has time to manually do analysis, to manually digitize, to do all sorts. So let's assume we want to do infrastructure monitoring. The traditional method would be you obtain your optical satellite imagery, like a time series, a before and after. Then you do the land use, land cover to see the changes. All that manual method. But now with the new tech in town, all you can do, you can train in the model. I mean, for example, Geo AI, you can use Geo AI, fine tune it, or manually train your model from scratch. Set it up also in the satellite such that once it's captured, it passes through the model that has been trained. So what gets down, it's a finished
A
result
signal,
of a
not noise.
signal, not
Yeah,
noise. So a result that has been acted upon by your model. So once it comes down, just the result, no
perfect.
manual process.
Yeah,
Snaps,
totally
comes
awesome.
down, take action.
Okay, amazing to hear this architecture and this cutting edge approach is in play at Proforce Galaxies Limited in Lagos in Nigeria.
Thank you.
It's so amazing.
It is.
I To me, to summarize it, really the satellites and the rocket launchers and all of this is a distraction. Actually, the way in this industry to get customers is to sell signals from well-tuned pipelines.
That's it.
And I think what that focuses the attention in the right way, because then it doesn't have to only be from satellites. There's all sorts of sources of signal, and plenty of terrestrial ones, including open data or social media feeds, even from street view, camera passes from vehicles going along roads. There's all manner of ways of doing remote sensing to generate a high fidelity signal that a customer will want to subscribe to in your suite of data pipelines. So yeah, lovely to have that message reinforced.
All right. So as I said, there's a whole lot of data. We not just only use satellite imagery, and because for example, similar companies in the West or in Europe, they focus more on their parts of country, like in, let's say, a company in the US focus more on US and its environment. So once we need data that is publicly available for Africa, it's not really nice. Like if you check USGS or Sentinel, you would see cloud covers and everything. So I mean, I don't really blame them because it's their country. No need for them to focus on Africa. So that's where we try to come in. We try to cover that gap, start small from Nigeria, Africa, then the world. So the gap that the top guys they kind of overlook. So we want to fix that. So we have like a unified upstream, downstream, and upstream, midstream, downstream solution just for Africa. Then we push out to the world. So that's what we're trying to do here for now.
That's so awesome. It's so inspiring. It makes me want to come down and meet you guys in Lagos.
Yeah, free.
Um,
You're free.
Speaking of which, are there any big conferences down there that people might want to know about?
Yeah, currently there is none, but if they are free to come and take a tour of the facility, because I said we are a subsidiary of Proforce. We not only part of us works on pure defense and security, so we create vehicles like tanks, NPCs,
So you're a
fully
defense
unmanned.
contractor as well.
Yes, so we create
Wow,
armored SUVs, tanks, etc.
crazy.
So there's a lot to for if they want to come for a tour, they are free. There's a lot to see.
Okay. I remember in the lead up to this, you were talking about an ESRI conference. Can you tell us a bit about that?
All right, so the last ASIC conference that I put in West Africa was I think last year. I forgot the month, but it was late last year in Lagos. The theme was digital. The theme of the conference was mostly about digital twin. I think the world is kind of everyone is kind of intrigued in 3D mapping, digital twin, smart cities, and it's
The
a nice
usual
thing.
themes around the world. Yep.
Okay.
Nothing new
So
there.
yeah,
Yeah.
we focused more on digital twin, and there was I think a representative from I think was it Dubai? Yeah, two representative of Esri from Dubai. They came over, so it was nice. We saw the new techs as we had in place, and we try to you know live up to the hypothesis because in this sector in this business we cannot really leverage on S3. We need to build our own platform that at least rivals S3. For example, now
I love this.
S3 has field maps, and the clients might come to us that they need something similar to field maps. We are not going to recommend them to get S3, but in turn we are going to build our own version of field maps that suits and can be modified to the customer taste. So those are the things we do here. We built our version of tools that has been already
That's
existing.
so cool. So you might there might be a GIS from Nigeria, GIS platform.
Yeah, I mean, yeah, we have some. We have inbuilt here, for example. We have inbuilt here. We have
Okay.
some
Is
ones
that
already.
only mobile but also desktop, or is it only mobile
Uh,
at the moment?
we have our mobile, web app, and desktop. Oh,
Okay. Oh, wow. Do you have like a product page for that?
currently, you can see everything on our LinkedIn page. We do post everything. So, for example, um, okay, let's see this. All right, so can you see my screen?
Yeah.
All right, so this is one of our products, GeoTrace. So GeoTrace was created for, as I said, it's a geospatial command and control. So with this application, let's use the military, for example. So let's assume the military wants to go for an operation and they want to monitor the operators on the field. They can use GeoTrace for that. So we connect this to satellite GPS so it can track assets on the field, basically anywhere. So any sort of assets, human assets, vehicles, anything, in as much as the asset has a version of GeoTrade embedded on him on the vehicle, so we can track the assets. We can it has an inbuilt communication system, so it kind of defeats the purpose of radios. It also has multiple intelligence, visual intelligence, open source, geospatial intelligence, and human intelligence. So it's all in one. It can use it for intel gathering. You can use
This
it for
reminds me of TAC.
reconnaissance.
So there's a similar one in
Oh
the
yeah,
US
yeah.
from.
It's similar. Yeah, limited
Amazing,
attack.
man.
Yeah. So it's kind of similar to ATAC for military that was created by DoD. So it's similar, but it's a version of that. So also it can also be used in utility, let's say pipeline, oil and gas pipeline.
I was going to
This time
say this is
around,
the system of monitoring that you can
yeah,
connect to the system of record and the system of engagement.
yes, it is. And it is. And again, it also serves as a database because anything you capture kind of saves. Come back 2 years time, 3 years time, you're going to see it. So the more people use it, the more value it gets. It feeds off the data. So it's game changing. It's really nice.
Obviously, a lot of talented staff and a lot of funding behind this because you guys have, you've got the hardware and the software happening. Yeah.
Yeah, there's a lot of guys here. We've got a lot of geospatial developers, software developers, computer vision, aerospace, a lot of team, a lot of good people on ground.
Yeah, no, it's amazing, man. It's so cool to just be able to get this insight from you, and it sounds really exciting. Last question. Are there any publicly traded companies like stocks you can buy in Nigeria that are related to this industry?
Currently, related to this industry, no, but we had a talk with GMD, that's the owner of the company, in few around last month or so. His plan was to get this company listed on the market. So
Yeah,
once we fully go live, hopefully, and I'm sure we would get listed on market, so it can be openly traded, Wall
that would be
Street and
so
everything.
cool.
Yeah,
Yeah. Oh, amazing. All right. Well, we have to stay in touch because I
yeah, we
maintain
will.
the Geo 500,
Yeah, so
which is
that.
the list of all, so I'm always trying to find new companies and IPOs are the most exciting of all. So,
Well, we
yeah.
are going to top the charts very soon.
Yeah. Awesome. Okay. Yeah.
Yeah.
Please, if you're going to have an IPO, please come on it and use it. Use the podcast to promote it.
All right, no problem. I'm
I'll be
always
so
open.
proud.
Yeah, it's all
All
right.
right. Abdulfatai Sanusi, absolutely amazing overview. You gave us insight into, you basically reassured me that there are common problems across the
Yeah,
utility industry. Everywhere
come
we
on.
try to do it. But it was also nice to hear about your successes and that migration. Often those data migrations do not go well. It was really nice to hear that you had a good story to tell about that. My mind is blown, and I'm really excited to hear about what Proforce Galaxies Limited is doing. And you guys are setting up your own constellation of satellites and your own signal pipelines. Great stuff.
Thank you very much. We really appreciate it. It's a pleasure to be here. I mean, from like once we end this meeting, I'm refreshing my YouTube, waiting for that to upload every time.
All right. Maybe next time we can do a live event, promote it ahead of time and have people
Yeah,
join live.
all right, no problem.
So I thought this episode was inspiring. First of all, we're very privileged that Abdulfatai spent until after 7 p.m. at the office recording an episode with us. Because of his effort, we have a rare insight into what appears to be a thriving geospatial industry in Nigeria. This all motivated me to check the Nigerian Stock Exchange for geospatial companies, and I came across three. They are Capitan Offshore Support Group, Julius Berger Nigeria, and MTN Nigeria Communications. Let's have a quick screen share, and I'll show you what these companies do. So the first one is Julius Berger. They're a construction engineering consultancy, design consultancy too. As you can see here, they have a BIM offering and a nice 3D model there. The usual sales pitch about why BIM is so great. So I put them in the BIM vertical, of course, of the Geo 500. Next is Caviton. You can see there some drones, and they've talked about some classic applications. So mapping, land survey, security operations, agricultural crop spraying, and they do training as well. So yeah, really interesting to see what's happening in the drone vertical of the Geo 500 in Nigeria. And last of all, we have from MTN, which seems to be telecom for the country, an asset tracking service, so location-based service type application from this company. So now that we have some examples of what these three companies do, you might be wondering how they've performed. Naturally, I've added them to the Geo 500, and as a group, they've performed extremely well, growing 32% per annum since inception. So let's dig into that a bit. Let's look at them individually. We're starting off once again with Julius Berger, and you can see it has grown in terms of capital gain 21% per annum, and the position was established back in 2012. You can see around 2024 there's been a massive uplift in this stock. In a similar way, with Caviton, there has also been a dramatic gain recently, although this company has only been in there since last year because that's when they began their drone offering. So, who knows if this 117% per annum capital gain per year is going to persist, but that's what it's been like recently. And continuing the picture, the positive picture, is MTN, Nigeria Communications. That's been in the index since 2019 and has shown, as you can see, very healthy growth, 27% per annum. So yeah, the picture is a rosy one. And I can only say, and I think we're all rubbing our hands together, we are really waiting for Proforce Galaxies, or Proforce as the umbrella company. It's overall a defense contractor, according to Abdulfatai. We're waiting with bated breath for them to also IPO, and then I can add a fourth Nigerian company naturally to the Geo 500. So yeah, thanks Abdulfatai and the team more broadly for representing Geospatial in Nigeria for us on the show, and opening our eyes to the enterprise, the entrepreneurship down there. Thanks very much.